Hello everyone, welcome to my channel. Today we will talk about production planning and control question. We have three questions. In question one, we will talk about before the solve question. We read the question. A toy manufacturer makes its own wind-up motors. So wind-up motors, which are then put into its toys while the toy manufacturing process is continuous. This is important. The process is continuous. The motors are intermission flow. The motors production process intermission. Data on the manufacture of the motors appears below. So we have five another data: annual demand, setup cost, carrying cost, daily sub-assembly production rate, and daily sub-assemble usage rate. So in a question 1, to minimize cost, how large should each batch of sub-assembles be? So to solve a question, we use production order quantity formula. What is this formula? Before solve the question, we write formula production order quantity equals 2 multiply demand multiply setup cost divided by holding cost multiply 1 minus demand divided by product. So it's our formula. In this formula we know all of data. To multiply demand, what's our annual demand? 50,000, and our setup cost $85 per batch divided by holding cost $85 and demand divided by sorry, in this part we write false. Okay, so the formula equals 7,288.7 and equals 7,289 units. Okay, in a question we use order quantity, we use production order quantity formula. In B question, approximately how many days are required to produce a batch? How many days? So we have to find required days. Again, insert equation. So So required days equals we use a data divided by production equals 7.3 days to make these units. So we pass question C. How long is a complete cycle? So we have to find cycle time. Insert equation. Cycle time equals, again we use a data divided by usage rate. To find cycle time we have to use usage rate equals 36 days. So we find C question and we pass another question, D question. What is the average inventory for this problem? To find average inventory we have to find maximum inventory before the find average inventory. So maximum inventory equals I max insert equation. What is I max formula? Theta multiply 1 minus demand divided by product equals, so in a question we find quantity and demand 200 and product 1000 equals 5831 units. So we find maximum inventory, but our aim is find the average inventory. So IH equals insert equation we use maximum inventory divided by 2. This is easy. 2950 units. So we find average inventory. So another question, the last question, question E. What is the total inventory cost of the optimum behavior in this problem? To find total cost, we have to find the total cost include 3 basic costs: holding cost, setup cost, and product cost. But inventory cost include holding cost and setup cost. So to calculate inventory cost, we have to find total holding cost and total setup cost. total inventory cost equals total holding cost plus total setup cost TC equals holding cost. What is our holding cost? To find holding cost, our holding cost 0.20 per unit per year, so 0.20, and we use average inventory. This is total holding cost, and total setup cost $85 multiply the number of setup we have to find. So number of setup, we use demand, annual demand divided by production order quantity equals 1166.19 dollars. So in this question we can see the question about the production order quantity. Any question we find quantity, order quantity. In B question, how many days are required to produce a batch? We find required days. In C question, how long is a complete cycle? Cycle time 36 days. And D question, the average inventory. To find average inventory, we have to find maximum inventory, and we use maximum inventory to calculate average inventory, and we find average inventory. In E question, we find total inventory cost. To find total inventory cost, we calculate total cost, and we calculate total setup cost, and the sum of these variables, this data, so you find total inventory cost in this question. Okay, we pass another question, question 2. So we have 6 weeks in question 2, and we have 6 different requirements. The time before the solve question, we read the question. The time first net requirements for the base assemble in a table lump over the next 6 weeks are given below. The setup cost for construction of the base assemble $200, and the holding cost is 0.30 per assemble per week. So we know setup cost and holding cost. Our weeks, 1 week, our requirements 335, and we have weeks and we have requirements. In a question, what lot sizing do you obtain from the economic order quantity formula? In B question, determine the lot size using the wagner-whittin algorithm, the best solution algorithm, of course. In C question, determine the lot size using the Silvermeal heuristic. In D question, determine the lot size using last unit cost heuristic. In E question, determine the lot size using the part period balancing heuristic. And last question, compare the total cost with ABCD and using lot for lot policies. So we solve a question, economic order quantity before solve question, economic order, quantity, formula equals square root and 2 multiply demand multiply setup cost divided by holding cost equals, so again 2 multiply demands. In this question demand, we have to find average demand. We don't know average demand, we calculate. And setup cost, we know setup cost 200, and we know holding cost 0.3. so before the calculate this formula, we have to find average demand. To find average demand, we use first week requirements plus second week's requirements plus third week requirements and fourth week requirements and 5 week requirements and 6 weeks requirements equals $269.17 at average demand. We find average demand, so in average demand we write here, and this data equals 599. so we find economic order quantity, so we can calculate total cost. And to find total costs, we construct a table. This table 1 2 3 4 multiply 7. Okay, so this is about week. Insert table, this is about week, this is about requirements, this is about production and inventory. So we have 6 weeks, 1 2 3 4 1 2 3 4, and requirements. What's the requirements? Copy paste. Okay, production inventory. In first week I have to product or order size 599. so for inventory I calculate 599 minus 335 equals 264. The second week our requirements 200, we have 264, so we don't use. And our inventory third week we need product, and our inventory 523. In fourth week not necessary, and our inventory 83. In 5th week we have the product and our inventory 382, and 6th week our product not necessary and our inventory 182. So in this table we can calculate total cost with using economic order quantity. We have 3 order point: 1 week, 3 week, and 50 week. 3 multiply plus and inventory first week 264 plus second week 64 plus third week plus fourth week plus fifth week plus and sixth week. Multiply holding cost is necessary, holding cost, because total holding cost we find. So total cost $1,049.4. So we solve a question with using economic order quantity. So B question: determine the lot size using Wagner-whittin algorithm. Again we construct table to use question. We copy this data and we copy production. So we are in here. In here we write 200 our setup cost. We write our setup cost. In here we write 200 plus 200 multiply 1 period multiply 0.3 equals 260. Here, so we add another SAS. And another SAS insert 260 plus to third quarter 140 multiply 0.3 equals 344, and we pass down 344 plus 440 multiply 3 multiply 0.3, but this is bigger than 200, so we don't calculate this part and we pass another period. In this period we use this plus so this comes from here, and this 200 comes from our setup cost, plus third week multiply 3 minus 2 1 period multiply holding cost equals 442, and we pass 442 plus we are here multiply fourth period second period difference 2 multiply 0.3 equals this is bigger than 200, so we don't calculate here, and we pass third week, and we look this and this 260 400, which is the minimum, which is smaller than, so 260 plus 460, and we pass another part 406 plus we use this data, and one period equals 592. And we continue plus fifth period 300 multiply 5 period third period difference of period 2 period multiply 0.3 equals 772. So we pass another part 772 plus last period, we are in last period 200 multiply 3 multiply 0.3 equals 952. So we pass another part. In this part we use this and this and this data, which is the minimum 344 plus 200 equals 544, and we pass another part 544 plus 300 multiply 1 period multiply 0.3 equals 634, and we pass another part 634 plus 200 multiply 2 multiply 0.3 equals 754, and we pass another part. So we look here which is the minimum. This is minimum, so we use 544 plus 200 equals 744, and 744 plus 200 multiply 1 multiply 0.3 equals 804. And another part, we look here, here and here, so 634 plus 200 equals, so in here, which is the minimum cost? Here is minimum cost, and we have to order fourth period and first period. So order point for this problem, first week and fourth week. We calculate so to use this table, we calculate wagner-whittin algorithm. Total cost $754. So we can see the minimum cost is here, 755. In equation we find bigger than $1,000. So we pass another heuristic, Silvermeal heuristic. In Silvermeal heuristic includes starting periods 1, cost, we find cost 1, cost 2, cost 3. In cost 1, 200 comes from setup cost for period 1. 200 divided by period 1 equals 200, and cost second, 200 plus 200 multiply 1 period multiply 0.3 divided by 2 period 130. So in this model, in this Silvermeal heuristic model, we have to find cost results. In cost 1, 200, in cost 2, 130. So the cost is decrease. We continue. Cost 3 equals 200 plus 200 1 period holding cost plus divided by third period equals, so decrease is continue. In fourth cost 185, so we can see 200, 130, 140 decrease, but fourth cost 185, not decrease, increase. So we write here stop. So start in period 4. So we calculate again and again. We find 200 plus 300 multiply 1 multiply divided by 2 equals 145. We can see 200 and 145 decrease equals 136.67. so decrease continue and we finish the period. So we can say we order in period 1 and in period 4. So we cannot calculate. We can calculate, but we can see our total cost in using Silvermeal heuristic. Our total cost $754 because in wagner-whittin algorithm and Silvermeal heuristic order point are 1 and 4 weeks, so our total cost is same $754. So we'll solve another algorithm, last unit cost algorithm. Actually last unit cost heuristic same as Silvermeal heuristic, but we use again step cost, but we divide it by not period. In this model we divide by requirements. Start in period 1, again cost 1 equals 200, but here divided by not 1, divided by requirements, so we find 0.597, and second cost 200 plus 200 multiply 3 multiply 1 divided by 335 plus 200 equals 0.486, and we can see decrease cost 1 and cost 2, and we calculate cost 3 0.500. so not decrease, it is increase. We write here stop and start in period 3. We calculate another cost 200 divided by 14, 140 equals 1 point. So in second cost we calculate decrease, and third cost 0.582, so not decrease, increase. We write stop and start period 5. So cost 1 200 divided by 300 equals 0.67, and second cost 0.52. 0.652. So we can see the decrease. So our order point period 1, period 3 and period 5. So when we calculate total cost $852. In the list unit cost we have 3 setup cost and another holding cost. When we sum of them, our total cost is here. So determine the lot size using the part period balancing heuristic. In part period balancing we find holding cost, we find setup cost, and holding cost minus setup cost we calculate, and absolute difference of cost we use. But a table to understand easily. 1 2 3 4. Okay, right here start in period 1. So I write here start in period 1, holding cost, setup cost, and different holding cost and setup cost, but we use in this difference of cost absolute difference. Here is absolute formula. Okay, holding cost minus setup cost so we write here the roof of problem. Start in period 1, or holding cost 0, setup cost 200, 0 minus 200. In second period, in second week, holding cost 200 multiply 1 period multiply equals 260. Our setup cost is stable 200, and differs of this data insert and third week or holding cost 144, again or setup cost 200, and difference, absolute difference 56. So we can see here 200 and after 60 and 56. So again we have to look decrease and to increase. We can see decrease, and fourth week 540 but 200. So stop. start in period 4. Clear data 4. Or holding cost 0 again, or setup cost 200, so absolute difference 200, and 50 period holding cost and setup cost and difference of holding cost and setup cost, and last holding cost 200 and setup cost, so difference. So we finish in this question, in this model, in this part period balancing heuristic, or order point 1 period 1 and period 4. So our total cost is same as Silvermeal heuristic and wagner-whittin heuristic. Part period balancing. So our total cost 754. So compare total cost A, B, C, D, E. In this question, to solve this question, we calculate total cost. We don't calculate lot for lot policies. In lot for lot policies, we write here means lot for lot means. We don't use any stock, and we use only setup cost. So we have 6 setup and we have only setup cost. So in this model, or total cost 1200. So it is the worst method. We calculate all of model results. So we pass another question, question 3. We have a company and different costs and different quantity. If quantity smaller than 500, the cost is $0.30. The quantity is $0.29. 500 and 1000 quantity between, and if quantity bigger than 1000, we use $0.28. So assume that the company considering what standing order the place with the use trash bags at a fairly constant rate of 600 per year. So our demand is 600 per year. The accounting department estimate that the fixed cost of placing an order $8 and holding costs are based on 20% annual interest rate. Find the optimum quantity. So we have to find 3 quantity, economic order quantity. We have to find economic order quantity, 0 equals, it use insert equation 2 multiply demand multiply setup cost divided by holding cost or interest rate multiply cost equals 2 multiply what is our demand 600 multiply setup cost $8 and interest rate multiply order cost and product cost equals 400 current order quantity so we find 400 in this part. We check it. The quantity is between 0 and 500. We find 400, so it is normal. It's not problem. So we find another economic order quantity 1.2 multiply but here we use and the result of formula 406 and here in formula we find so it is normal. We check, but here we don't check yet. In here quantity is between 500 and 1000, but we find 406, so we cannot use here, use it. Or economic order quantity equals 500 and second economic order quantity 414, and we know our quantity bigger than 1000, so we cannot use it. So order economic order quantity for equals 1000. So for 0.400, so first point 500 and for second point 1000 order quantity. So which is the best solution to estimate total cost? We write total cost formula. Total cost production, we have to find total cost 0 and total cost 1 and total cost total cost 1 and total cost 2. We have to find this data. Total cost insert equation total cost equals 0 equals product cost 0.30 and demand 600 plus average inventory or inventory for first model 400 divided by 2 multiply holding cost interest multiply and cost plus we find total holding cost and total setup cost. Demands divided by order size multiply ordering cost, total ordering cost equals 204 dollars, and another calculation we find this and this. So which is the minimum total cost? Total cost $198. It is smaller than 0 point and second point, so we use this economic order quantity, or economic order quantity equals 500.